So good afternoon, everyone, and welcome to this webinar. So my name is Eric Chwamunjoya. I think we have already had the occasion to meet at some point during this project. For those whom I haven't met yet, I'm the project manager of Multimodex, and I would like to thank you for making the time this afternoon to attend this webinar. So the Multimodex team has worked tirelessly over the last month, and have is now in the position to present the first result of the project. And so we expect then this afternoon to share with you the results that we have obtained from the work that we have accomplished over the last months, and also get feedback from the stakeholder, enable to prepare the final document for the final event in November. So as you are all aware, Multimodex is so set out to create innovative solutions that integrate air and rail planning to enable smoother and more sustainable journey across the continent. And this is achieved by developing 3 tools. So the performance assessment tool, a schedule design tool, and a disruption management tool. And the focus so far has been on Spain, so looking at intra-Spain connectivity, but also long-haul connection via Spain. And with the end result, or the so the vision is to get a scalable approach that can be adapted across EU by developing passenger archetype and regional archetype. And expected impact include time and cost saving for passenger and operators, reduce emission through smarter modal choice, more resilient transport network, but also one of the aim also is to lay out the foundation for future higher TRL technologies. But without further ado, I would then pass the floor on to the solution leader to present in more detail the different solution and the different findings from the work that have gone on over the past months. So I would like then to I don't know whether STU we have Jerome in the room and Virginie. If you would like to say something, but if not, then I will then invite the solution leader to start the presentation of the solution.
Yeah, hi Eric. No, nothing from my part, so just go ahead.
Okay, thank you.
Thank you.
So, so the first presentation will then be given by Luis on the performance assessment solution, so solution 1, and Luis will then present. So the focus here is really passenger-centric framework for assessing multimodal solution, including definition of KPIs and evaluation mechanism to analyze strategic and tactical impacts. So Luis, please.
Thanks, Eric. Yes, so I'm going to present an overview of this solution 1 in Multimodex, solution 399 within the project. And as so I'm going to present a little bit the capabilities of what we have developed here in a very high level. So initially, the first thing we wanted to achieve is to have a multimodal modeling and evaluation framework, and to support the design and development and the assessment of strategic multimodal solutions. And by that, we mean schedules, timetables that can be provided or generated. and also to evaluate the impact of replanning the network considering disruptions, and what could be the impact also of having mechanisms that support tactically on the day of operations multimodality to mitigate the impact of such disruptions. And to achieve this, we have mainly worked with 3 different components. The first one is to develop the multimodal performance framework, which is, as you will see, a set of indicators to capture multimodality. And then we have developed 2 tools that allow to actually do the evaluation, the strategic and the tactical evaluation. And something that I will mention a few times, as you will see, is that all the work we have done within this solution, we wanted to share with the community, so everything is open source and accessible. So feel free to review the actual outputs and reach out after this presentation if you want more details. So first, some strategic considerations, and something worth to mention is the difference between strategic and tactical for rail and air and other modes, and that's what I wanted to do this first introduction. When we talk about the strategic in this project, we mean the scheduling phase, so when we are still building the schedules. When we are doing that, something that is very important is to keep in mind that we have network-wide effects, because the behavior of passengers can change the whole system. So for example, if we have here a map of Europe and we have a passenger that is traveling from the northwest of Spain to Madrid, because they are connecting flights, because they are going to fly to New York, for example, and then we do a change in the schedules, like for example, we remove that short-haul flight, we will expect that maybe passengers will move towards multimodality, but it could also easily be that they may choose a different hub to do their connections. And by that, what I mean is, like, when we modify the system, we need to see how the passengers will reaccommodate to the new set of options at a network level. On the other hand, when we look into the tactical considerations, we are looking at the day of operations, so how the day of operations unfolds. And what we want to do is to ensure that the connectivity that we have, particularly in multimodality, is ensured, right? So passengers are able to make the connections. And that can be tricky because we have different systems working at the same time. We have trains that can or not be on time. We have, of course, the air side, where we have flights that by their nature can suffer also some type of disturbance. And of course, if we are transferring between the different modes, passengers may require to use like ground mobility, like metro, buses, or local regional trains, which also could have some type of impact. Or even the airport itself could have some problems at check-in security or congestions. So altogether means that there are many places where the passenger may end up taking longer than planned. And what we want to see is like, okay, if we have this planned network that is optimized so passengers can go through the system in a very smooth way, when that planned network materializes on operations, how robust that is, how many passengers are actually missing the connections, and can we do something to support them so that that doesn't happen. So this is the overall framework of multimodics, and I'm focusing in this red box in the middle, where, as you can see, is the multimodal performance evaluator. I'm going to very briefly mention or discuss these 3 boxes that are inside. The first one is the performance evaluator. So as I said, we built a catalog of indicators, which is a digital catalog of indicators. And by that, we mean that it's available online. It's passenger-centric. And again, it's open, collaborative. So we focus on different performance areas, as you can see here, like operational efficiency, capacity, interoperability. And the indicators we developed focus on passenger-centric indicators, like, for example, what is the total journey time, how much are the buffers that passengers have in their itineraries, or what is the catchment area of the airports, considering multimodality, for example. These indicators, that can be many of them, we analyze them in the framework of the CISA performance framework. And by doing that, we came with this idea of have this 3-level approach, where we have indicators level 1 will be indicators that can be mapped or can be promoted directly to the CISA performance framework. Then we have indicators level 2, which are currently being used by multimodal projects such as Multimodics or others. And then we have level 3, which is like more desirable indicators because they capture the actual mobility of the passengers. But maybe they are more like exploratory research because there is a lack of data. Maybe we can come across with some modeling, but it's more difficult to characterize. In this level 2, following a workshop we held in London, we defined 2 subcategories. 2.1, it's candidates to be promoted to the social performance framework, and 2.2, they are currently being modeled in multimodal projects. So all this that is a little bit abstract, it gets specified in a Confluence space, which is a wiki type site. And as you can see, we have a table with all the indicators defined. And for each one of them, you can see what is the highest maturity level we think that indicator has. And by entering in the subpages, then we have a definition of the indicator. So we follow a little bit the approach of the ICAO framework, where you can have this type of information. And as I said, it's open source in the sense that it's available to the community in Confluence in an open page. So here you have the link, and I think this material will be made available after the presentation, so you can have a look yourself. The idea is that this should be taken forward in the future by other projects and in a collaborative way help to define or redefine the indicators, so we don't reinvent the wheel every time we have to work in this field. Then if we focus into how to evaluate the networks, we have, as you can see, the 2 evaluators, the strategic and the tactical one. Again, all the code we have developed for this, it's open source and available in GitHub, and it's a set of tools. So we have like 2-3 tools that can be run and utilized. They have been developed in Python, and as I said, they are readily available for the community. So first, on the strategic multimodal evaluator, the idea is to be able to evaluate, so compute the performance indicators we showed before, the planned networks in a multimodal perspective. So as you can see, we have on one hand the demand with passenger archetypes, the origin and destination, which is not necessarily at infrastructure level. So it's not from this airport to that airport, but from this region to that region, because we want to see the impact of modifying the schedules, for example, and then maybe people will shift between modes, even if they can still reach their original destination, for example. We have passenger preferences linked to the archetypes that Eric mentioned before. It can be at a European level or at a Spanish level, sensitivities of choices and things like that. And then on the other hand, we have the supply. And the supply is mainly the schedules from the airlines, the timetables for the trains, constraints in who can work with whom in terms of alliances, for example, prices, infrastructure characteristics, minimum connecting times, and so on. And what we want to do is like we can modify the demand by modifying the archetypes or modifying the demand. And we can also modify the supply, for example, by optimizing the schedules, having different timetables. And also, very importantly, you can see here in the corner.
Can you hear me?
Yes, sorry. Okay.
So, sorry.
Oh, okay. We have here the policies, as you can see, and that's something we want to be able to modify. And by policies, you will see some examples, but we mean, for example, a flight ban or a regulation that makes emissions more expensive. That's going to impact prices, for example, and therefore it's going to impact the preference of passengers to options, right? So we want to have a tool that allows us to evaluate these type of things. This is a very high level presentation to show how it works. So you can see, for example, we have the demand between this region in the northeast to this region in the northwest of Spain, and at NUTS 3 level. And what we do is try to compute the possible options that sort of make sense for the passenger. So a passenger could fly from Barcelona to any of these airports. And you can see that Barcelona airport is not even within the origin region, but it's within the catchment area of the region. So people can go by car to Barcelona and then fly, for example. So this is different options that they have. Of course, they could fly via Madrid and connect. So we have connecting flights. But they could also get the train. And if they do that, they will get, for example, the high-speed train from Girona to Atocha, then change to Chamartín, which means a change within the city to get another train to La Coruña, for example. Or they could have multimodal tickets. And by that, we mean that they could get a train from Girona to Barcelona train station, which is integrated with a flight to allow them to fly. So we can compute all these different options. That's what the code does. And then considering the total traveling time, door to door, so from the region of origin to the region of destination, the total expected cost of that trip, and the emissions, we have a modal choice that allows to distribute the demand between the different alternatives. And that's what allows us to evaluate, plan, and replan networks, because we can modify the schedules or modify any of these parameters and try to see how that translates into changes in demand, for example. So of course, the metrics can be computed at the region level, at the infrastructure level, we mean airport or rail station, at an operator level, like one airline in particular or one rail operator and so on. And this allows us to evaluate the schedule designer that we will see in a minute, but also the disruption management. So if we replan the network, then we can try to see what is the impact on the passengers. Some examples, as Eric mentioned, we focused on the intra-Spain mobility. So we have demand at NUTS 3 level within Spain. We have policy packages that we develop, and you can see in this table the 3 of them that we evaluated. The first one is like no particular policy, so you can buy a ticket integrated, but it's up to you as a passenger. So what we did is to increase the minimum connecting times between modes, because we assume passengers will be more conservative. Then we have multimodality incentivized, where we reduce the time that it takes to go between the airport and the train station and the other way around to the real minimum connecting time. And we add some cost to the emissions of flights. So we assume there is an environmental tax for aviation, disincentivizing a little bit the flights. And then we have what we call multimodality enforced, which mainly means that we also apply a fly ban on short-haul flights. So if there is a train between the regions of less than 2.5 hours, then we remove the flight. We have the infrastructure characteristics, minimum connecting times, processing time of passengers, and things like that. And we can also have disruptions that we can evaluate. So very briefly, some of the results to show you the type of thing we can do. We started with the calibration of the model. So the input were historical flight schedules, historical rate timetables, values from planning apps like Google Maps to get the minimum connecting times and the traveling times. Then we were very lucky that one of our partners have anonymized mobile phone network data. So with that, we could get actual information of the itinerary of passengers in the door-to-door journey, which allow us to calibrate the preference model for passengers. And as you can see here in this example of the calibration, you can see in the figure 3 different options to go between Madrid and Barcelona. Madrid, sorry, and for the different passenger archetypes, how many people we can see in the data from mobile phone data that choose those options, and how many people the model is predicting that will like those options. So the matching is quite well. There is still some error and room for improvement, but we were happy with that overall. And then finally, for the tactical evaluator, the calibration was based on trying to estimate that the simulated times make sense based on previous projects and reported data. So some example of the results. I'm going to compare very briefly, for example, the baseline with respect to the multimodality enforced, where we have the flight ban. When we apply the flight ban, mainly what happened is like all these origin destinations, two from Madrid, the flights disappear, because in Spain you have the high-speed network that support those connections in less than 2.5 hours. And this is just an example to show how we can do at a region level, for example, estimate how much of the demand is being served between a given origin and destination at a NUTS 2 level. So you can see this is in the baseline scenario. Of course, yellow means that all the demand who wanted to do that is being satisfied. Then we apply the fly ban, and then we come to this other case. So you can see there is some changes. So there's some regions that maybe are better served, some regions that maybe have some demand that is not satisfied anymore. So that allows you to identify where some mismatch between capacity and demand may be happening in terms of supply. Something you can do also, of course, is aggregate the data, for example, in terms of door-to-door time, and get an idea of how long does it take in average to go from a given region to other regions within Spain. So here you can see, starting in Barcelona NUTS, how long it takes in average to reach other regions. And there is no big surprises, but you can analyze how going to the west of Spain, it takes much longer because the connections are not very good. And maybe other regions that are farther away, like Madrid, actually is very well connected, and you can reach it relatively fast because you have high-speed train. The interesting thing is not only being able to have these values, but being able to see what is the impact of having different policies, as I mentioned before, or different schedules. If we focus on infrastructure, we can look, for example, in this case, we are looking into Valladolid Airport, which is this secondary airport located here in the northwest of Madrid. And we can see in the baseline scenario how many people flew to Valladolid to then continue by train to other regions. And you can see here the demand, which is relatively low, and which areas that is happening, right, where people are going. when we apply the flight ban, even if we are banning the flights going to Madrid, an effect that we identify, for example, thanks to this model, is that the amount of people who actually use Valladolid as a regional connecting hub to continue the trip by rail actually increases, and more regions are being reached through that connection, and also like the total volume of passengers connecting goes up, as you can see. So we are banning flights in Madrid, but then people who before were flying to Madrid to continue their journey, now they are flying to Valladolid instead. So we can capture this sort of non-direct effects of policies. Or here, the last example, you can see the amount of connecting passengers per rail station, and if they are connecting to other trains or if they are connecting to other modes, right? So you can see the ratio of multimodal passengers at different train stations. Finally, with the static evaluator, we can do a replanning of the network. In that case, what we do is to assume that something in the network is not working, like we can have an industrial action or close an airport or close a train link, try to identify which are the passengers that are being impacted by that, and find which alternative exists for them. So how the passengers will be reaccommodated in the remaining capacity of the system. This is just to show an example. In this case, we have closed the link between Madrid and Barcelona, the train link. And we have different policies in terms of how to reaccommodate the passengers into the remaining capacity in the system. And I don't want to get into the details of this. We are working on some publications to try to disseminate this. But mainly you can get an estimation of how many passengers end up being stranded because they were planning on getting the train. Either that was their only journey or they were connecting thanks to that train and now they cannot do it anymore. And then as a function of the flexibility that we increase, we allow, for example, to move from having booked a train to be able to get a flight, or from having booked a given train to be able to go a rerouting route and things like that, the amount of stranded passengers go down. So we can analyze what is the impact of that flexibility that we can provide to the passengers when they are being disrupted. And of course, we can do this with the planned network, or we can do this with an updated network that takes into account the disruption. And this is another image where I think it's quite illustrative of, for example, how many passengers are being affected by the disruption, how many are being delayed, how many are still on time, how many got cancelled part of the service and need to be replanned, how many can be rebooked, how many can stay in the same mode, but they changed the path. So they were planning on connecting in a given airport and now they are connected through a different one. So you can get a very good sense of what passengers are doing in the network to try to react to the disruption that we are modeling. And you can see that in some cases we can have non-direct effects. Like, for example, here we close Madrid airport, and originally we have someone who wanted to fly from Malaga to Madrid, and instead now they are getting the train to Cordoba to change to get the train to Madrid. So they are starting a different node from the airport to the train station. Now they have a connection that they didn't have before, and they swap modes. But by doing that, they are not stranded anymore. So that's, again, the type of things we can try to assess. And finally, because I think I'm running out of time, for the tactical multimodality evaluator, mainly what we have developed is a simulator that allows to track flights and trains, but most importantly, passengers in the system. So this has been built in Mercury, which is a tool we have developed over 10 years, and we have added the multimodal capabilities of simulation. With that, we can try to see how, when you have a network that has been planned or replanned, you have a set of flight schedules, timetables, and passenger itineraries, we can add disturbance, we can add delays, we can add either nominal day-to-day small delay or stress conditions, and try to see how the system reacts, mostly focusing, again, in this case, on passenger connectivity and passenger delay. So as an example, again, of the capabilities, you can see here that we have modeled Madrid airport with the connectivity with Madrid train stations, and we are assuming that the ground connectivity has some type of issues where there are delays of half an hour. And mainly we have a mechanisms that allow you to reduce the time it takes for passengers to go through the airport. And we can simulate how many passengers will miss the connection. And as a function of how fast you can make that mechanisms work, how many passengers will then not miss the connection. So quite low level details, but just to show the capabilities of the tool. So wrapping up, the benefits is that we have a transversal multimodality evaluator framework and a set of tools. We have a common framework that we hope can be developed forward in terms of performance indicators, and we have tools that allow to evaluate plan, replan, and also realize multimodal networks. And it enables the evaluation of other solutions and mechanisms, and very importantly of policies, because then we can evaluate what is the impact of some of the policies that otherwise the decision making is not based on actual numbers. And in conclusion, the performance framework is built on the literature, but collaboratively, and we hope that it can become a permanent catalog of indicators that people can reuse and contribute to. The strategic multimodal evaluator can assess these networks and as I said, support the evaluation of new scheduling or new infrastructure development. And finally, the tactical evaluator allows you to see how robust your planned network is, and also to evaluate other mechanisms that are supporting that connectivity on the day-to-day of operations. So that's it. Thank you very much. If there is any questions. I know there is quite a lot to cover in a very short period of time, so please feel free to review all the material we have produced and come back to us if you have more specific questions. And otherwise, we would like also if you are kind enough to share with us how do you think these tools that we have developed and this framework can be usable or of interest of you, either on your research or on your practice, or future lines of development that you can see could be promising based on what we have done here. That would be quite useful for us to get the feedback if you have anything to share here on the spot.
Hi, here is Mari from Swiss. Can you hear me?
Yes, please.
Yes.
Oh, great. Just so I'm not the expert in multimodality. We have a team just for that in Switzerland, like a Swiss airline, and I know they're working quite a lot also with train connection. Of course, will be quite interesting if you have some documents that I could provide to them, and then they will come back to you if any questions or with more specific feedback, I guess.
Yes. Thank you, Mari. Nice to hear you. We definitely have quite a few deliverables and documents that explain all the results and the capabilities of the model. So I think we can share those with you. And we are currently working on a white paper just focusing on this solution to try to explain with more details what we have done in terms of this, and also a more broad one covering the whole project. So I guess all that can be disseminated once it's ready, so you can share that with your colleagues.
Yeah, that would be great, especially like also with the white paper so that they can see on the overview. Is that interesting for them? And yes, if yes, then they can really deep dive. Sure.
Yes.
Hello, everyone. I'm Bing Liu from TU Dresden. I'm going to present the solution 400, which is schedule design solution. The solution leader is Lucia from Norman. Okay, so the schedule design solution aiming at enabling an integrated planning of air and rail networks that optimize the waiting time at the transfer nodes and try to offer more and better options. And as what we can see in the framework of the project, like we're here, strategic multimodality solution. So we design the timetables. And here you can see the working process or framework of the whole solution. So we have some input, which includes the demand characteristics and the supplies. And then we need to define what kind of demand and service we need to focus on. We don't want to focus on some demand like there's no need for transfer at all because we are synchronizing the timetable for transfers. And also there are some services we don't want to touch. So we will select the demand and the services. And then what we'll do is we will do the synchronization. So we coordinate the services and also do a kind of passenger assignment. And then we have the output, which is synchronized real timetable and the flight schedules. And this is for solution 2, but we also try to integrate it more to solution 1. And thank you, Luis, just present the solution 1, and we try to evaluate our synchronized timetable again by the strategic modality evaluator and give some performance indicators and to see how good is the timetable. And also we need the input from the strategic evaluator to see how the demand will change and start another iteration. And now we'll start with the define scope. So for demand, we want to focus on the transfer demand, which means the itineraries with at least one transfer. And also we focus on the majority demand. So itineraries with demand more than a threshold, because we don't want to focus on 1 or 2 person. And for the services, we choose the services used by the selected itineraries, and also some other potential services which may improve the system, which are serving the same segments as the used services. And then here is the key module of the solution, which is the synchronization. So what do we do to the synchronization? So we do a time shift strategy. So we have initial timetables, and then we shift some of the shift some of the services, and then in the synchronized timetable, we will have better and more connections. And this is not the whole story. So if we shift the timetable, and the passengers will also shift their itineraries to use better connections. So our question is considering the supply and demand interaction, how to redesign timetable to improve the passenger transfer experience. So then we have a model like this. We have supply and demand as inputs, and our decision variable in the model is the timetable and the passenger itinerary. And we also include some of the operational constraints and the passenger assignment constraints in the model, including the running time of services like trains and flight, and dwell time mainly for trains, and time shift range, because we don't want to shift the service to tomorrow. We need to have a range for that. And for train, we also consider train headway for the safety issue, and for flight, we consider the airport capacity. And for the passenger assignment, we consider like the demand should be served as much as possible, and also the service capacity is limited, and also we need a minimal connection time. And for objectives, we have 2 perspectives. For passengers, we have we will try to minimize the unserved demand and the transfer time, and for operators, we want to minimize the timetable deviation to avoid unnecessary timetable shift. And then we have our output. And here comes some results. So after we have more OD pairs and demand and solutions, demand and services in the original data set. And after we define the scope, this is what we focus in the synchronization. So, and here comes to the results of synchronization. We compare the benchmark and the aerial synchronization. The benchmark is the initial timetable. We don't do anything. And we can see from the results, the synchronized multimodal system is better than we designed the timetable separately. So more demand is served and less transfer time for all types of transfer, like air, rail, or multimodal. And we also compared flexible demand and fixed demand. Flexible demand means we allow passenger to shift the itinerary, and fixed demand will assume the passengers will just use the original itinerary, even if we shift the timetable. So we see the itinerary shifts happens and the results, and also it results in a better performance, which means we should consider the flexible demand. And now we zoom in a little bit. So for individual passengers, what happens to them? So then this figure present the transfer time decrease for each individual passengers, and we see most of the passengers have a shorter transfer time, And some passengers encounters longer transfer time, but in an acceptable way, and we only have a few passengers. And we also see how we also try to analyze how passengers why passengers have a shorter transfer time. So some of them just because of the time shift, because they don't shift the itinerary, just the connection get better, so they have shorter transfer time. And for some of them, they change to some new connections, and then they gain a shorter transfer time. And we can see 1/3 of passengers shifted itinerary to reduce the transfer time. And for the services perspective, if we have a look at the timetable deviation, so we can see most reach, like if we shifted the timetable, most reach the maximal. So which means now we set the range of the time shift is 20 minutes. So if we increase the time shift range, maybe we have a potential improvement. And also when we have a look at the connections, we see there are better and more connections generated in the synchronized timetable. And there are also some worse connection generated, but actually typically they're not used by passengers. And for this one, it's all in solution 2, which is the synchronization. And now we try to combine solution 2 with solution 1, and which means we give the synchronized timetable to solution 1, and then we evaluate it again, and then we do the iteration, we do the synchronization again. And what we can see from the results is the number of connecting passengers increases, and also the total journey time decreases. It's at the network level. It's not only in the scope we defined in solution 2. It's for all the OD pairs and the system performance. And we do multiple iterations, and then we find the performance improves over iterations. And here comes the solution and the future research. We have a multi-objective optimization model for aerial timetable synchronization. And we find consider itinerary shift will depict a more realistic system and result in better timetable. And the proposed method can improve both connecting passengers and travel time. So, and also we try to iterate with solution 1, which improves the performance. And for the future research, we would like to try more strategies, not only time shift. Maybe we'll do something route-based. And also we want to, now it's only timetable, we want to see how this kind of adjustment will affect other operation plans like rotations. And also we want to evaluate the impact on different operators, like how this kind of timetable adjustment will change the market share or their profit. And that's all for solution 2. Thank you and welcome any of your questions. I probably also want to ask for some suggestions for the future, like what kind of strategies you think will helpful in this kind of synchronization, and also like how to make it happen in practice you think is important, like how operators will how to say, like how operators will agree to do this kind of adjustments, like what their considerations, like if there is any suggestion from the industry board, I would be appreciated.
Yes, Andrew, please.
Yeah, well, I don't count as the industry board since I'm sort of on the inside, but thank you for the nice presentation. My reflection would be that I would really strongly support under the future research looking at the impact on the operators and how this could work with multimodal business models, essentially, because I think this is a key element of this area of work where some future research and models would be extremely valuable. So I think we have on the one side the synchronization and the modeling, which is fantastic work in Multimode X. And then I think the next stage would really to have a good focus on the business models and see how that works in terms of integration. So I would really like to see that coming in future work that you flagged on your slide. Thank you.
Yeah, thank you, Andrew. Yes.
Pleasure.
Yeah. Thank you very much, Andrew, for this very interesting point. So yeah, we have yes, please, this is Marcus.
We cannot hear you, I think.
You're muted, Marcus.
Classic, absolute
There
classic.
we go.
I want to pick up on the very good point that Andrew made. That the next piece of research, probably, if you look at how this then gets operationalized, is you have a range of actors who are not incentivized currently to collaborate in terms of the airlines and the train companies in particular. So I think part of the work needs to be looking at motivation and incentives as to actually how to get this to work in practice.
Yeah, yes, thank you for the comments and suggestion. And actually, yeah, we are also considering this and also get a lot of questions on that, like as an airline, why we would like to do it. So probably we can have some more research on the business model or even how to use some policies and the regulations to motivate them, because we are gaining something by the synchronization and how to distribute this kind of benefit and in which way.
I suspect you'll struggle on the business model in the same way it took like the French government to ban internal flights to drive up rail usage within France. You kind of probably need that, because actually, short of the airlines starting to operate train services, which I don't think is part of this particular proposal, then they're only going to lose revenue. And, you know, I'm not an airline expert, but there's an awful lot of economy of scales. The more things you've got going out of a single airport, the more profitable you can be. So actually, this whole model arguably is a reduction in profitability for airlines and an increase in profitability for trains. I mean, you could argue it will drive up demand in general. However, if I was an airline, I think that's how I would look at it. So the incentivization needs to be clear, and I think that needs to be a legislative fix. And I think that this whole commercialization legislation is probably a whole business model by itself. Oh, sorry, a whole module by itself.
Yeah, thank you so much. It's like the comments is very valuable, like for our future research on the business model.
I would just very briefly agree with Marcus. I think if you look at the three types of incentive that we might have, then one, if you want to call regulation an incentive, then I guess it's an obligatory incentive. So we've got the three incentives of regulation, capacity constraint, and profit. So it might be that there's an intermodal cooperation, which is basically driven by a lack of short-haul capacity, which is sort of pseudo-corresponding to short-haul ban. So that's pushing operators into intermodal behavior when they have a requirement by regulation or by capacity constraint. Otherwise, I agree with Marcus, it's difficult to see where a pure profit mechanism is coming from. So it seems to me the regulatory components and the capacity constraints are likely to arrive before the profit model. It seems to me anyway. Anyway, it would be very great to see this in the future, as we said. Thanks again.
Yeah, thank you, Marcus and Andrew, for these good points. And I think also we're planning some kind of discussion and collaboration with other flagship projects such as Signer and TravelWise. And I think during those discussions, we will probably get some insight also on this point and how maybe to develop further this project or these points. Any further question? Shall we then move to the next presentation? Okay, yeah, is this Chris?
Yes, sure.
Okay, yeah, thank you.
So I will take over. So yeah, it should come up any second. Yes. So can you give me a sign if you see the screen, like the shared slides? Nice. All right. So let's get started. Yeah. So I'm Christopher Shimula from TU Dresden as well, a colleague of Bing. And I'm about to introduce the third solution, which is solution 401, the disruption management solution. And the challenge there was to provide actually a multimodal disruption management, which can improve the network performance under disruptions. And we actually had a closer look on how to coordinate air and rail schedule adjustments in combination with passenger adjustments to achieve this. And of course, we then evaluated the overall mechanisms. Yeah, so you can see in the figure that we are now capturing the very last part on the most right, which is the tactical multimodality solution. And what we are actually doing is we wanted to coordinate multimodal schedules. So if you take the air network management as a base to start from, we actually wanted to imagine a world where we could do the stuff not only for air networks, but for multimodal networks, which means air and rail in combination. And so that's actually the setup. We are basically assessing where we can handle disruptions or in a coordinated manner. And we wanted to figure out what's the impact on the respective network performance. How did we do that? Well, we actually started with a 3-layered model, which is consisting of an infrastructure layer, which is the infrastructure such as airports, stations and corridors. And there we basically operate services on which then provide capacity for passengers. And by using this model, we can actually model the disruption management for one mode, but also across multiple modes. And the challenge was then to actually optimize the disrupted operations for the day of operations. So to optimize the vehicles, flights and trains and passengers, considering the passenger perspective, but also the operator-centric metrics. And what we actually do then is we take like the input data, which is what I said, like the network, the OD data, the service features and the disruptions, in combination with the passenger features and the schedules. And then we do what we call operating the disruption management model. So we actually manage the disruptions of the individual modes and simultaneously check on what's the consequences for the passenger's multimodal routing. And as an effect, when we finish the optimization, we get actually modified schedules which are adapted to the disruption and maximize our respective objectives, which is in our case balancing the gains for passengers, but also the expenses for operators. And those adjusted schedules can then be fed back, to example, for Louis to do the in-detail assessment. He already showed his capabilities earlier. Yes, and so what we are considering is for passengers the total journey time, which means the traveling, the transfer, and the waiting. And on the operator side, we basically consider the operating times and a diverse set of disruption management mechanisms, which comprise of diversions, delaying services, cancellations, and even scheduling replacement services. And to give you an idea how this looks like, so take this fictitious network for now, and we have like a disruption over here. So if you imagine like a train running all over the way here, then we could basically reroute the train, which basically means it just takes a different route. And another disruption measure would be the cancellation. So of course our train of interest is then not operating anymore at all. And then, of course, we also have the diversion. So where we actually take a completely different destination to schedule our service. And this is basically the disruption management measures we have. And then we figure out what is happening to the itineraries. So if you check on this itinerary going from all the south via Madrid to the east, then you can see if there's like some disruptions happening, then there is a new itinerary which serves now the passengers in a different way to get to their destination. And now we wanted to figure out what's the optimal set of disruption measures to actually balance what we are doing. And we gained some insights because for that we conducted some experiments and we evaluated like the similar experimental setups which were presented earlier, which consist actually the setup without policies and with policies. For us, we considered the with policies where actually multimodality is enforced, and we considered for the presentation now one disruption scenario which is like a massive capacity reduction at Madrid airport and the respective management decisions. And here you see the problem size, which is actually about like 1,700 flights, slightly lower amount of trains, and around about 300,000 passengers. And what it looks like is, and what we produce then for the solutions is actually the timetables. So this is like the final output, but of course also we assess what is happening, and we defined like some KPIs in the project, which are measuring the impacts, which are the delays, which are the total journey times of passengers, stranded passengers, but also numbers of cancellations, diversions, and replanned passengers. And then, of course, we assessed all this to figure out how many passengers suffered from increased travel times, and we visualized like all the increases and decreases on different legs in the network. And the overall results look like this. So if you consider like the nominal setup where everybody is like traveling just as normal, but we have multimodal tickets, Luis introduced this scenario already, we wanted to see how disruption management has an impact on the network performance. And because we are on multimodality and we already talked about how operators are willing to cooperate or not, we assessed like two different setups, which is actually uncoordinated disruption management. So every operator does like just consider its own operations and its own passengers, and the coordinated disruption management, assuming they are basically working together to see what's the potential benefit of this collaboration. And we compared this to a benchmark, sorry. So that's what I'm showing here. And I will just show you the percent discrepancy to this benchmark solution, where we don't do anything, just like canceling the services which cannot run and then let the magic happen and passengers find their ways. And what we can see that for uncoordinated disruption management, we see that actually many of the KPIs are improved. We can see we have a lower delay. We have similar numbers of disruptions. We have a slightly lower average passenger journey time. We decrease in stranded passengers, and we have more replanned passengers, which is naturally right because we do something. But what we can also see is that disruption management is happening jointly. Then we can even gain more. So you can see that the delay is reduced, the average journey time even further, and the stranded passenger numbers are reduced as well. And that's, of course, nice because it shows that there's potential, even though it does not answer the question which you already raised in the questions to Bing's part, how to get people, or especially companies, to operate like that. This is still a question to be tackled in the future. We also run into interesting results when we were comparing another scenario, which was with policies, which makes actually multimodality was enforced, because then the picture was slightly different, because we could see that actually uncoordinated disruption management even led to like some increases, so decreases in performance when it comes to passenger journey time and stranded passengers. So at the benefit of reducing the delay, we could actually, it could actually happen that particularly the multimodal passengers suffer, and we also have some passengers more even not reaching their destination. However, no surprise, in the multimodal and forced disruption setup, we get better, like lower number of stranded passengers and comparably number of delay. However, we have a reasonably higher average journey time, which is because we now reconnect even the far distant parts of the network, which results in an increase. Yes, so you see that it's not everything super super obvious unless you take the experiments to figure out what's actually happening in the network. So you see that there is a benefit of multimodality even in disruption management, and even more if we can make coordination happen in disruption management. What we provided until now is the multi-objective optimization model to actually assess multimodal disruption management. We could show the relevance of the network performance, so it's not enough to look at like some particular links. I mean, it's the entire thing of the whole project, right, to get a feeling and the grasp of the entire network. And we can show the importance of comprehensive traffic management mechanisms and the coordination behind. Of course, there's still some steps to the future, which is we need to design some paths to integrate actually this theoretical framework into actual action. So how would it happen in the network managers frameworks? So what organizational changes and software changes are required? And of course, we also need real-life calibration with stakeholder input, because for now we are basically still doing stakeholder-inspired, but still academic research. And of course, it's also important to capture transition phases before and after disruptions, and also the uncertainty parts in the disruption management mechanisms, to actually reach the far future point where we actually go towards real-time traffic management decision support, or even crisis management decision support. For now, we reached the end of the presentation, so thank you for your attention. And if you have any questions, feel free to shoot them now. Andrew, please.
Yeah, again, sorry, I'm a bit of an imposter since I'm inside or on the edge of the project. But anyway, thank you for a very nice presentation. Again, I would take the liberty, if I may, to again agree with a key point on the future research. One of the elements you flagged, and for me that would be the calibration. It seems to me we're hearing a lot in the news now, unfortunately, and I think it's going to become more prevalent on cyber attacks on airports. For example, Heathrow, Dublin, Brussels recently. We had the isolated fire at Heathrow as well, which caused a 24-hour outage, and on top of strikes. And in recent discussions with colleagues in Brussels and Arlanda, it's interesting to talk with them about the extent to which they're taking quite detailed data of passenger reaccommodation, what happens at gates, and so on and so forth during these crisis incidents. So I think, as you put on your slide, calibration using real-life case studies, which are very unfortunate for the industry, but provide us with potentially very good sources of data for calibration. And I think it's always amazing that no matter how wonderful the sophistication of the really nice modelling that you've shown, I think all of us inside the industry and outside are very surprised by the different types of resilience and behaviour which passengers can invent to get from one place to another. It's really quite remarkable what happens on the ground, and even just this 10 or 15% of really unexpected behaviour, self-reaccommodation, and the system through the passenger behaviour trying to reach a new equilibrium can be really insightful. So I think that type of collaboration would be really interesting. And so that was a little thought from me, and thank you for the really nice slides. I really enjoyed the presentation. Thank you.
Yeah, thank you, Andrew. I mean, I can just agree on every point you said. I also was like writing when you gave the comments on Bing solution, because that one-to-one also maps to us, where we are also about motivation, incentives, and business models, right? So you're completely right when also following on the data part and keeping both, like making things happen and also calibrating to catch what's actually happening and bringing it a bit closer to reality.
Brilliant. Great. Thank you for the really nice slides. Thank you so much.
So if there's no more questions, maybe I can spark some. Alessia, please. Oh, you are muted. I believe.
Can you hear me now?
Yes.
Okay. Hi, good evening. I have a question. Like I was just wondering, for what concerns, so take into account the disruptions and so on. Like how did you handle the affected passengers? So, did you consider already existing alternatives, or did you like look into possible new alternatives?
So what we actually did is we did a complete rerouting of the affected passengers whilst also adapting the services. So we did basically both. We adjusted the services and then checked the alternatives which are available to the passengers and rerouted them. But we also adjusted the services such that they will provide beneficial alternatives. So it's kind of a simultaneous thing or iteration where you adjust, check how beneficial it is, and then adjust passengers and so on and so forth. So basically we do both. Yes, but we come up with existing but also new alternatives, and then based on that we reroute.
Right, thank you very much. And did you, by any chance, also look into different type of passengers, like whether they were business or tourist passengers, and take that into consideration? Or
for now we didn't take into consideration different types of passengers. I mean, it's incorporated into the model, but it would suggest some kind of level of detail we actually don't have because we don't. In the project didn't have the knowledge about how passengers behave during disruptions, right? And this behavior, which is distinct from strategic behavior of demand, doesn't exist even for general passengers, nonetheless for like specific passenger groups. So we didn't go for that, even though I would suggest I would expect there is like significantly different behavior. But for now, we consider just what was given to us by the other solutions, and then did the disruption management, assuming people would behave the same way they did in the long-term strategic way. But considering the real-life disruptions, that's a future challenge as well.
all right, thank you very much.
Okay, so maybe if you don't have any questions, you might have probably some suggestions for me, because similar to my colleagues, we are of course wondering, or I'm of course wondering, what is necessary to go the next steps, to also provide like some ideas to the people who might work on the follow-up projects, and suggesting things in our white paper to come into existence, right? And of course, also to put forward what we discovered here. So if you have any suggestion into what's necessary to go and put this into application in the future, like so for make it usable for you actually in your work or research, or what do you also see what is most necessary? I mean, we had some things actually with Andrew, but also now with Alessia. What is most necessary to get the fingers onto for future? And also what do you see missing? That's of course interesting. So if you have any suggestions with regards to those 3 points, please feel free to give them. Andrew.
Okay, I would just add a small footnote on the issue of the business model, and that would be, I think, a key element in that is the cost of capacity, which we never really, or the cost of capacity specifically for resilience. So I think we often talk about, I mean, there's one thing getting the data to know what is the capacity in aircraft and onboard trains, but I think one thing which I didn't see modeled yet, and I think it would be pretty challenging, would be to understand at what cost that could be provided. So we've spoken about the possibility of having X seats on a train or an aircraft to help make the system more resilient. But we know these seats are always sold by operators at the last minute at a much higher cost than the ones in advance. So if we were to ask an operator an airline or a rail operator to, okay, how would it work if you had 15 seats per vehicle or whatever at this time to help the system be more resilient under disruption? What would the cost of that be, and when would you buy them, and when would you release them? Because if you buy them a year in advance, they cost very little. If you want them to still be there on the same day, they will cost an absolute fortune. And I think the skill for us in the business model is to work out how would that work? When would they be bought? When would they be released? And how does that fit into the business models? That seems to me quite a tricky thing for us as an academic and business community to think how that works. So that's something I would find quite interesting, at least.
Yes, that's completely true. And it might be also interesting to see how cost of capacity holds for even infrastructure, right? Because it's not about only seats, it's also about airspace capacity, rails,
Yes,
and stations and airport. And if it gets into millions, whether to provide additional infrastructure built, that's also a challenge, how to justify that.
exactly. Thank you.
Yes. Okay, thank you. Marie, you have
Yes,
something,
hi.
please.
Just to react to what Andrew said, actually, what is for now happening is that we always have bilateral agreements. So within airlines, we have agreements with group of airlines. So within our group, like the Lufthansa group, for example, or going outside with the Star Alliance, or going even outside with any airlines. And we do have the same also with some train operators, which means when we rebook our passenger, we have kind of fixed cost already, or it can be a bit variable, but it's everything in the contracts. So I will expect, even if we go really on scales, as you foresee in your project, that we just will go on scale also with all the contracts we will have to deal with.
But yeah, just a short announcement that we are preparing 2 events. One will be on November 12th, and it will be at the European Parliament. And we will discuss multimodex outcomes together with 2 other projects, Signair and TravelWise, and it will be more on the policy side. And the next day, November 13, it will be solely dedicated to multimodex, and it will be our final event. And yeah, Vanessa, thank you. If you are still not registered, please use the link in the chat. I think, yes. Can you send both links, please? Let me check, because it's 2 different registrations form. Yeah, it's very difficult to enter the parliament, so that's why we have 2 different links. Yeah, we will be waiting for welcoming you there, and yeah, we keep in touch. Yeah, thank you, Vanessa. Now I see. Yeah, there are both links there.
Yeah, thank you, Alina. So I'm sure you have already received the invitation. So we will keep sending a reminder close to the event, and really would be happy to see you all in Brussels in November, and to continue the discussion, and also how we could improve this work further. So your feedback is really well appreciated. So from the solution leader, are there any other point, any other point from your side, Luis? Is it?
No, I just very quickly, I added in the chat the link to the GitHub repository where there is the open source of the models, both the strategic and the tactical and the replanning, and also the link to the performance framework Confluence site. So again, it's fully open there. So if anybody wants to review it later, it's there. Feel free to reach out if you have any comments or questions after this meeting.
Okay, thank you, Luis. So if there are any other question or comments, then I would like to thank you again, everyone. So the solution leaders, the multimodal team, for the excellent work, and also to Jerome and Virginie from SGU for the support, and all the stakeholders for the feedback during this process. We had 2 validation workshop, and your feedback really help us to develop these tool that we have now been able to present to you. And as I mentioned earlier, we will be presenting this in more detail in November in process, and we're looking forward to welcoming you all there.